As a continuation of our exercise 8 series, the final element of this exercise series are the dimensions. There are different types of dimensions for different types of situations to be measured. We will tackle the different types of dimension and how to set it up. The dimension toolbar is labeled here as annotation. Okay? So the different types of dimension is located on the top right corner of the annotation toolbar here. So the different types of dimension will be displayed when you click the scroll down menu. So here are the different types of dimension. So let's start measuring. So we need to start with linear. Linear dimension only measures horizontal and vertical distances. So if I'm going to measure this inclined line, I'm going to click at the bottom endpoint and the top endpoint. Notice, there. You'll say, sir, walay dimension. Actually, it is there, but it is very tiny. Okay? So we need to set up our dimension. Okay? To do that, we need to go to the Dimension Styles menu. So you type the shortcut D, enter. So here's the Dimension Styles Manager. So we are using standard, and then it is very tiny for now. So let's go to modify. So select standard and then modify. There. So we have our different tabs that needed to be set up. So let's tackle them one by one. So let's go first to line. So here we can edit or modify the elements of the line, the color of the line type of the line weight of the line. So color is basic, what color it is. Line type meaning what type of line are we going to use for the dimension. Is it a hidden line? Is it a boundary line? Is it a zigzag line? Is it a section line? But in our convention, we will use the current solid line. The line weight pertains to the thickness of the dimension. Among the drawing elements, the dimension should have the thinnest line weight. We will be discussing that when we start to create plans. Now, arrows and symbols here. So you could actually choose whatever endpoint or ticks or arrowheads you want to use for your dimension. So in here, the default arrowhead is close filled. So you could change it to close blank, or if you want an open arrowhead or an open 30-degree arrowhead, or even an architectural tick, which is very familiar to us, or a dot. You could have a closed dot there and dot blank there. Okay, so it's up to you. For now, I'm going to use close filled. Then the text. In the text, you could change the font, the color, the fill color, the text height, meaning how large the font of our text. And then the placement. You can have it centered, above the dimension, outside. So let's just go for centered. Now the text alignment is important because you could actually have it all text horizontal. So even if the dimension is vertical, the text will be horizontal. But it would be best, or it looks well, if the text is aligned with the dimension. For one, it saves space because you could stack your dimension close to each other, especially on the vertical part. Because when you choose horizontal, it kind of creates a space here, wherein you need more space if you have a stacked dimension. So you could go for aligned, but for me, the best text alignment that's provided by AutoCAD is the ISO. I prefer ISO just because of the alignment of the angle or the radius dimension. So if I go for ISO, there, it is horizontal. Now, AutoCAD automatically have scaled its dimension to a more proportionate scale. When I say scale, meaning the size of the font or the text compared to the size of the arrowhead, compared to the size of the extension, it is fairly proportional with each other. But the problem is, when we change the size of the text, we also need to change the size of the line extensions, size of the arrowhead, and we might be confused. To make our lives easier, we will choose fit. Okay? So basically, when we change the overall scale of the dimension, everything will be scaled up or down equally. So the proportion of the text, the arrowheads, the extension line is the same. So now the overall scale is 1. If we increase this 1, everything will also increase. So there will be no need to individually change the arrow size, the lines, and the text. So let's change that later. Let's go to primary units first. So in primary units, of course, we use decimal. And the precision pertains to how many decimal points we need. So basically, the convention in our profession is 2 decimal points. And then the decimal separator should be period. Okay? Next, we go to angular dimensions. So in the angular dimensions, it pertains to the angle. So this one is decimal degrees. You could choose degrees, minutes, seconds. And for its precision, the same with the precision for the length dimension. You could actually create this or choose this there, or you could have seconds. It depends on your convention, but the common convention is decimal degrees. And then, so let's go to fit. Okay? So let's try to change, since it's very small, let's increase it by 10. Enter, then OK. So do not forget to press set current, so that what we did in modify will be applied in our drawing. Set current, close. There. So now our dimension is kind of clear, but for me it's still small, so I'm going to go back to the dimension modify, and then modify. I'm going to increase it a little bit, around 15. Okay, set current, close. There, much better. So let's proceed. So linear, if I'm going to measure this one, again, only horizontal and vertical dimension. If you want to measure the true length of this line, you will not use linear. Instead, you will use aligned, because aligned is set up to measure true lengths of line, or it will go parallel to the line you want to measure. There. Next, angular. So angular measures linear angles and angles from arcs and circles. So basically, if you're going to measure linear angle, you just need to select the lines that create the angle. In this case, the angle is created by this diagonal line and this horizontal line. There. So we have our angle. So if you want to measure the angle of this arc, you just need to select the arc and drag. Automatically it will measure the dimension of the angle of the arc. Next to that is arc length. Arc length is different from angle because it actually will measure the length of the arc, because you cannot measure it using linear, aligned, and angular dimension. It's different. So let's click arc length. Click. There. So basically the length of the arc, when you measure it, it's actually 117.81 meters. Then let's go to the last two types, the radius and diameter. The procedure of these two is the same. You just need to click the radius and then click on an arc or a circle that you want to measure. For example, this circle, click. Okay. This one, click. Now for diameter, basically it measures the diameter. So for example, the radius of this circle is 25. So obviously its diameter should be 50. There. Now you will notice that the symbol changed from radius to this diameter symbol. So that is how we identify if the dimension given is diameter or radius. So basically, that is how we create dimensions. So you need to apply this to our exercise 8 series in all the figures given. Thank you.